Okay, so we're going to get started today, and we're going to continue working with complex surfaces. So last time we were in Rhino, remember we took a break and dealt with some V-Ray stuff. Now we're back into Rhino. The last time you guys worked in Rhino, we built those pillows and whatever, and we worked with curved networks to create complex surfaces. We're going to do something very similar, but on a larger scale. So we're going to deal with some topography today, and I think that's a good way to learn how to manipulate and work with complex surfaces. We'll spend the next three lectures dealing exclusively with this piece of terrain. Next class, you will get your assignment 202 handout, and then we will actually spend exercise 212 and 213 working on getting ready for that assignment 202. So you can do a lot of the work in class. It will help walk you through a lot of the steps. So I'll walk you through all of that. Today's kind of the precursor for it, getting ready, getting our feet wet, and practicing. The nature of the next three lectures is there's a lot of repetition. I will go slower in the beginning, and then I'll speed up and then cover new stuff, and then I'll speed everything up and cover even more new stuff as we go forward. So you'll get some repetition, but it seems to work nicely in terms of teaching people how to do this part of the process. So the first thing that we need is we need some kind of a source of the terrain information to begin with. You could have terrain information coming from a surveyor or from some model that pre-exists that was given to you as part of your design process. For our purposes, we're going to pick a piece of terrain and use the SketchUp Geolocation feature to get that piece of terrain. It's not the most accurate piece of terrain in the world, but it is a place to start, and it's something that everybody can pick from. So that tends to be a good thing. So as much as SketchUp is not my best friend, though I do have to teach it, so I have to be somewhat friends with it, today we're going to get into SketchUp just a little bit. So if you've never touched SketchUp, it's not the end of the world, but we need to get our terrain information from SketchUp. So I've gone ahead and I've opened up the SketchUp 2019 on this computer. I'm going to pick the architectural template in inches. Make sure you are in inches because it's going to throw everything off if we're not in inches. When SketchUp opens, I can go ahead and I can delete the little person that automatically comes in. We don't need him whatsoever. Then I'm going to go to the File menu and go to Geolocation, Add Location. So it's File, Geolocation, Add Location. And I can then go and look for, it'll bring up, there we go, there we are. You'll bring up some location. You can pick any location for this that you want. I would encourage it to be something that has some hills and some terrain to it. If you pick something that's really flat, you're not going to get a lot out of the exercise. So pick something that has some terrain to it. I would not pick something like Half Dome at Yosemite where you have a vertical cliff. That's going to be really hard to build. So we want somewhere kind of in the middle ground, something that's reasonably mountainous but not overly steep. And so I think for me, I'm just going to pick a spot near Lake Tahoe. Something like that should work just fine. We'll zoom in here. Let's go more like right about there. That should be kind of entertaining. When you zoom in, you'll notice that at a certain level, you'll get a white square that will show up. That white square is the maximum amount of information that you can grab from SketchUp at a time. So as you start to zoom in, you can zoom in further and the white square goes away. We're looking for a fair amount of good information, so having the white square, that's about the maximum information we can get. Once you have that and you've picked something, go ahead and click on the Select Region, and it'll give you the little selection. And then you can click the Import button. And this has actually changed a little bit in this version of SketchUp. The 2019 is a little different than previous versions. The button used to say Grab, and so now it's Import. And it will bring in a file for you. It looks like just a flat plane with a photograph on it. However, if we go to the File menu and we go to Geolocation and we go to Show Terrain, we can look at what this piece of terrain looks like. So there's my piece of terrain. That looks reasonable. If you end up picking a piece of terrain, you get it afterwards and you say, I don't really like that very much, just create a brand new SketchUp file, go back in and do a new piece of terrain. SketchUp doesn't like it when you go back and try to grab it again once you've already brought terrain in once, especially if they're far apart. It gets cranky about it. So better to just create a brand new SketchUp file and bring it in that way. So now that I have my piece of terrain that I'm going to work with, I'm going to go back up to the File menu here, and I'll go to Save. And I need to save this into my folder for today. And let's see, where are we? We're in 211. There we go. And on the handout, it says to save as SketchUp 7. We updated Rhino. Yay! So we don't have to save the SketchUp 7 anymore. Actually, we don't even have to back save at all. We can save it as the 2019 version, and it'll come in just fine. So that's great. We'll just click on the Save button. No back saving required. Perfect. Now we'll go ahead and open up Rhino. I'm going to choose the Large Object Inches template. And once I've opened that up, I'll go ahead and go to the File menu and choose File and then Import. Notice I'm not choosing Insert. I'm choosing Import. So I'm actually bringing all of the SketchUp data directly into Rhino, as opposed to trying to reference it as a block. Once I've done that, I need to go to today's folder. And there it is. And I'll go ahead and click on Open. The SketchUp Import Options dialog box will pop up. SketchUp models differently than Rhino. Rhino models things as smooth NURBS surfaces defined by curves mathematically. SketchUp models polygons. So we get triangles and squares, and that's what defines our surfaces. You guys have probably noticed this when you've tried to create something that's curving or circular, that SketchUp always divides it into little facets. It's never really perfectly smooth. Same thing happens here when we're bringing this in. That means it's going to come in as a mesh object, which is a little bit different. We haven't dealt with meshes before. That's fine. All of the default options here are fine. We'll go ahead and say OK. Oh, come on. I just tested it. Really? Let me back save and just see if that'll make a difference. I did just test this, I swear. There we go. I don't know. It worked fine the first time I did it, so maybe you have to save it as a 2018 version. I apologize if that ends up being the case. What I did was I went to File and then Save As, and under this little drop-down menu here, I just went back a version. You can go all the way back to version 7, which is what the handout says, though you really don't need to. OK, so now that I'm back over here in Rhino, if I were to zoom out in the perspective view here, we can see the terrain that came in. And if I switched into shaded mode, we could see it a little bit better. SketchUp brings in two things. One, it brings in this mesh, and we can see all the little triangular facets that make up the mesh. And it also brings in a flat plane. The flat plane ends up being a little bit useful down the road because it has, if we switch over into rendered mode here for a second, it has the picture plastered on it. We can use the texture mapping on this surface to match the mapping later on if we need to. So I like to save it as opposed to just deleting it. So I'm going to switch back to shaded. I'm going to go over into my layers and take a look at my layers. So it looks like I have a layer for location, which contains all of the data that I brought in from SketchUp. I'm going to go ahead and organize this a little bit more. That one gives us basically nothing. I'll call the master layer here SketchUp. And then I'm going to create two sublayers underneath it. The first one will be plane, and the second one will be SK terrain. Or let's call it mesh to be a little bit more clear. And it will do SK plane here. Just trying to be clear. I'll take the plane, I'll put it on the plane layer. Let me go to change object layer. And I will take the mesh and I'll put it on the mesh layer. We'll go again to change object layer. There we go. I can delete this last layer because it doesn't have anything important on it. And so now I've kind of clarified things. I have my SketchUp. I'll turn off the plane because I don't need that. And I'm left with just the mesh file here. So I was able to bring that in. It's not bad, but if we were to look, say, right here at the peak of this, see how these facets end up kind of approximating the shape as opposed to it being a nice smooth shape. If we're farther away, it's not the end of the world. But we want to take this shape and we want to convert it into a nice smooth Rhino surface. So we're not dealing with the mesh anymore. We're dealing with an actual surface. And so that's what we're going to go through. I have a tutorial written out for this. It's Rhino 5.23 and Rhino 5.24. So if you end up getting lost on what I'm about to do, just go back and you can watch those, and then that'll help you through it. So as I start to create this, I need to find a way to accurately convert this object into a nice smooth mesh. There is a command in Rhino that's called mesh to NURBS. And I can use that command, and I'll show you that right now. I type in mesh to NURBS, like that. It says select polygon meshes. This would be my polygon mesh. I can go ahead and hit enter, and it's going to create the mesh for me. There it is. And when it does that, there's my poly surface. I'm just going to move it over here so you guys can see it. Okay, it creates it. And it is, in fact, a Rhino poly surface, but it's still all faceted. It's still made up of all these little individual pieces. If I were to explode it, for example, I'd end up with all these individual little triangles, which is not really the most useful thing. We want to be able to adapt this and convert it into one complete smooth surface without those facets. So instead of doing it that way, we're actually going to use a command called contour to give ourselves some lines. And this should start to look a little familiar to how we created the cushions later on. So I'll show you. So let me work with my layers. The more organized you are here, the easier this is going to be. I'm going to take layer 1, I'll double click on it, and I'll rename that to be contour X. You could call it contour 1. And I'll take layer 2 here, and I'll rename it to be contour Y. There we go. Let me make contour X the current layer, so I'll double click on it. There it is, right there. It's the current layer. And when I use the contour command, I can type in contour. Otherwise, I need to go to curve, curve from objects, and then contour to select it. And it's going to ask me first to select the objects for contours. And so I'll go ahead and pick this object as my contour object. I'll hit enter to confirm that. Then it says contour base point. It would be nice to snap to this corner. The regular snaps, my end, my mid, and my perpendicular that I tend to have on, won't help me snap to that corner because this is a mesh, not a surface. So it doesn't actually have the traditional endpoint on it. So in that case, using either vertex or not are going to get us close. I'm going to choose vertex, and there I'll be able to select it. So I'll pick this corner. Now, at this point, I need to go direction perpendicular to the contour planes. And this always takes a little bit of understanding. I'll let you watch me do it, and then it'll start to make a little bit more sense. Essentially, what it's asking for is it's asking for what is the direction that is perpendicular to all these contour lines that I'm going to create. So in this case, if I went along the x-axis here, I've turned on my ortho, and I'm not snapping to anything. I'm not snapping to the corner here, nothing like that. I'm just going off into space exactly in a line along the x-axis. There it is. Then it'll ask me the distance between the contours. I'm going to do that at, say, 100 feet. And so when I do it, it's going to give me a bunch of parallel lines, a bunch of curves, right along the surface. Let me turn off for just a second the SketchUp mesh so that you can see this a little bit better. Well, that was not useful. Oh, I forgot, sorry. I have my OpenGL tessellation turned on. Now we can see them as nice smooth curves. So what we should see is a series of nice curves that then go along and represent the surface. Now, You guys see that? So the contours, these are parallel lines at a given distance apart that basically are slicing through my object, is what I'm creating. I'm going to do that again. I'm going to choose the contour Y this time. I'll make that active. Let me turn back on my file here. And I'll go ahead and I'll take my mesh. I'll go back to curve, curve from objects, contour. Same little base point here, but this time I'm going to go along the y-axis. So I'm going off in space this direction. And I will again pick my distance between contours at 100 feet. And it will then create a series of lines going in that direction. Let me turn off the mesh so you can see it. So I have one set of contours going along the y, and I have one set of contours going along the x, in this case the red and the purple lines. You guys kind of see where I'm going with this, right? So these lines now, assuming that I have lines on the edges that are nice and clean, could end up being a curved network. And that's the direction that I'm going to build a complex surface from these individual pieces. Now, let me back up a step because there's an error that people run into right here. And that is that they end up doing the second contour when they have the lines from the first contour still selected. So if I have those lines selected and I go right back and do contour, and I start at the same base point here, and I go off along the y-axis, and I go ahead and say, yes, it's 100 feet, and I hit enter, I end up with a whole bunch of individual little points. So in this case, I contoured all of those lines, and I got points. So we always want to make sure when we contour a surface or a mesh, not a set of lines. So if you end up with all these little points, that's a mistake. Go back, delete the points. Or if you accidentally got to this point and you say, oh, wait a minute, I deselected them, how am I going to go in? No, you don't have to go in there and select 1,000 of these little points. You can type SEL followed by PT to select points. Press enter, it will select all the points, and then you can press delete and have them go away. So once again, on this contour Y, I'm going to go ahead and select the surface, go up to curve, curve from objects, contour. My base point is going to be right there at that vertex. We're going to go right off in space along the y-axis here. And I'll do those again at 100 feet. And I'll create that series of lines. The other thing that can happen, that I've seen happen, is people do a contour. And they start here going in the same direction. And they say, not 100 feet. Remember, this is a really large piece of terrain. And they say, OK, well, I'm going to do it at 1 foot. Well, when we do that, it's creating lines every 1 foot along these. We don't need that much information. The triangles are only so big. Or only so small, I guess, would be the right scenario. Obviously, I'm going to stop that. I don't need that to keep going. So our goal here is to create our contours such that they're about the same size as whatever our triangles are, because we're not going to get much more accurate information than that. So 100 feet tends to be about right, which is why I guessed at it. You could do it a little bit more precise if you want. You could do it at 50, but you end up with a lot more curves that you really don't need. So let me go ahead and turn off the mesh, and that's going to leave me with my contour X and contour Y layers. There they are. So at this point, remember on a curved network or a network surface, I need the edges to be defined by one curve all the way around. And I have, if I look down at this, I have a bunch of little ragged pieces hanging out. I have two options here. I could use this option here and choose this second piece, curve, interpolate points. And I could actually draw a curve that goes right along the edge, snapping to each end point. That would be one option to create the curve that ends the network, the curved network, or the network surface. Or I could switch over into my top view, zoom out a little bit, and use my trim command. I'll use that as one of my trim lines. I'll use this as one of my trim lines. I'll use, well, we'll make life easy. I'll use that one as one of my trim lines. There we go. And I'll use that one as one of my trim lines. So I've selected those. I'll type trim or go to Edit and then Trim, and I'll delete off all of those pieces that hang out past those borders. Sometimes you have to zoom in a little bit to make sure you got them all. Yeah, I got them all there. And we can trim those off like that. Once I'm done, you can see that this now forms a nice little grid. If I look at it in the perspective view, same thing. It's defined nicely by a set of curves. It's good. So I trimmed off the excess. If you look in the top view and you don't see a perfect grid, something went wrong when you did the contours. And you see like diagonal lines or something, something's wrong, and you probably need to go back and redo the contours. So I'm going to go back into perspective view here. There it is. I'm going to switch my layers. I'm now down on layer 3, and I'm going to call this, we could call it terrain. You just need to name it something. And I'm going to go ahead and perform my curve network. Before I do this, however, I'm going to save my file, because sometimes the curve network, because there's a lot of curves, can crash Rhino. It's Rhino 6, so I doubt it, but it's still worth saving anyway. So I'm going to go to File and then Save. And in today's folder here, I'll go ahead and click on Save. Perfect. So now it's time to do the curve network. Remember, if I go up to Surface, it's called a curve network. If I type in the command, it's the opposite. It's network surface. I don't make the rules, so it's one or the other, network surface or curve network. I'll go ahead and press Enter. It says select the curves in the network. I'm going to select all of these curves like that, and I'll go ahead and press Enter. Now when I do that, it's going to say calculating a surface for more than 100 curves can be slow and may cause Rhino to become unstable. Yeah. OK, do you want to continue with 117 curves? Yeah, I'll go ahead and do it. If I did it correctly, I should get the A, B, C, and D around the outside of my curve network. We'll see if Rhino decided to crash on me. Told you that was a risk. No, but it's still thinking. Go ahead.
I've had like 3 computers and they're all having that, and a couple other people having that problem.
Oh, so you can't log in and yeah. Mine actually went down earlier today and then it came back, but we'll see. I'll submit a ticket. If that's the case, it is what it is. Okay, so I was able to go ahead and it popped up my curve network box. You will notice at this point that everything becomes really slow. And that's because this is a very complicated surface. Once I'm done, I hope, I'll be able to say OK, and I will. The other thing that you can do is you can change the edge curves and the interior curves tolerance. You could drop it by a 0. So you could say 0.01 for the edge curves and 0.1 for the middle. That might help speed things up a little bit. I'm going to go ahead and say OK. Cross my fingers, wait for a little bit while Rhino does it. I might as well be the one that tests it out and see if it crashes or not, right? So this is an exercise in patience. Got to let it work its way out. So I'm going to go ahead. I'll pause the recording for a second, and I'll come back. It may take a couple minutes to finish, but there's no reason you guys have to sit here and watch me. You guys can get started finding your SketchUp terrain and bringing it in, etc. OK, so my did finish, and I got this big blue block. The reason it's blue is because the density of the curves that it created are really fine. The first thing that I need to do is I need to single click on it. And again, this is an exercise in patience. I'll single click on it. That big blue block will turn yellow. There it is. If you have all 4 views showing, it will take even longer for all 4 views to turn yellow. So you just, again, be patient. Once you're done with that, you go ahead and type in rebuild, or go to edit and then rebuild. And we're going to rebuild this big surface. Again, we wait and are patient. And we're going to rebuild that for our point count in U and V here. We're going to go 200 by 200. And we'll go ahead and say OK. As soon as it's done, Rhino picks back up and it's fast to move again. And so when we look at this surface, and actually I'm going to switch the color into something that you guys can see a little bit more. I'm going to turn off the contour X and the contour Y, and we're going to look at the surface that I created. So when I rebuilt it at 200 by 200, you can see the U and V values are already smoothing out the triangulated mesh a little bit. We can look there. But you can still see holdovers from that triangulated mesh. You see the little bit of the triangle that was there, etc. We can choose to smooth this out even further if we want to. And so for you guys, you'll do this rebuild. You'll rebuild to 200 by 200 and then decide how much more rebuilding you want to do. I'm going to show you this in contrast so you can kind of see how it changes with some different rebuilds. So it's not something that you guys will end up doing, but it helps illustrate the point a little bit. So I'm going to go ahead and copy this, and I'll do it in place, and I'll move it onto this next layer. And so I end up with, let's make this the active, I end up with my original here. That was at 200 by 200. This one here, I'm going to rebuild that again, but let me make a few more layers. I'll call this one 150. I'll create another layer for 100. I'll create another layer for 50. And I'll create another layer for 10. Again, that's not something that you guys need to do, but it will help me illustrate what's happening. OK, so I now have my original at 200, this next one here at 150. Let me convert it over so that the color is a little bit easier to see. So when I rebuild this one, I'll select it, type rebuild, and I'll do this at 150 by 150. Now in this case, if we look at our surface, it got a little bit smoother, but not too much. And I can do it in contrast to the old one. Let me change the original one's color. And you can see that the parts where it's where we're seeing the gray coming through, that's where it's smoothed things out a little bit. So it's editing the surface. But the bulk of what we're seeing is essentially the same. We can still see those holdover triangles. If I move on and I move to this next one, which I'm going to do at 100, and I change to 100 by 100, here, it's smoothed those out just a little bit more. Oh, come on. There we go. So we can start to see that little dip here is going away. It's getting a little bit smoother. If I were to turn back on the original, you can see that there's much larger areas, larger patches where it's smoothing things out in contrast. Let me turn off that original. Let me turn off the 100. I'll go to the 50. I'll type in rebuild. And we'll go at 50 by 50. And now if we look at the top of the hill, it's almost perfectly rounded. It's really smooth. We've lost all that detail. If I were to contrast it with the original, you can see that it's really kind of smoothed things out. So the original had these little bumps on it. Now this goes right through and it's just nice and smooth. If I were to take this even a step further, to the 10, for example, and I took this and I said rebuild, and I said let's do this at 10 by 10, and I said OK, it's going to be extraordinarily smoothed out. But at the same time, I've lost a huge amount of the detail. So I've cut this mountain, if we knew what the distance was, by a couple hundred feet. I've just chopped off the top of the mountain. So I've lost a lot of the detail that's available. So if you go too far with the rebuild, you lose too much of the detail. So it's going to be your job to determine how far the rebuild really belongs. So is it something like this, where we want to see a little bit of that triangulation? Maybe 100, that's getting pretty close. 50 might have been a little bit far, so maybe this 100 here, maybe a rebuild at 80 might be just the right amount, where we're getting rid of that triangulation, but it's smooth enough to look pretty good. That's going to be your job to determine what feels right. I think it needs to be a little bit more, maybe 75. There we go. Yep, I think that was the right one. So it smoothed it out just enough. I haven't lost too much of my character, but I've kept it and made it a little bit smoother. That will be your job to determine. Once I have this surface, that's good. We're going to move forward into the next kind of piece of this. And today it's actually rather simple, because this is really what I want you to concentrate on, being able to create it and then ultimately rebuild it. We will build on this next class. But at this point, I want you to use the contour command one more time. So I'm going to go ahead and create a new layer. And I'm going to call this Topo Lines. And so this is going to create topo lines like on a map. Like if you were looking at a USGS map where it has topo lines every certain number of feet, we're going to do that using the contour command. So let me make the topo lines layer active. There's the check mark next to it. I'm going to change the color right now so you'll be able to see it in contrast here a little bit. And then I'll use the contour command again. I'll go to curve. And why is a curve from objects? My brain stopped working there. Contour. I'm going to select my surface here as my contour. I'll press enter. My base point is right there at the corner. That's the end. Now this time I'm not going to go in the X direction. I'm not going to go in the Y direction. I want to go straight up and down in the Z direction. I'll probably need to switch over into one of the side views, either the front or the right side view, to be able to go straight up and down. There it is, going straight up and down. And now I'm going to type in a value. Typically a USGS is every 40 feet, so I'll go ahead and type in 40 feet, followed by enter. And it will then go up my mountain here. You'll see this looks like the typical topo plan. This one here has all of those in 3 dimensions such that we'd be able to see, okay, that's what it looks like every 40 feet going up vertically. So one more piece of the puzzle that we're ultimately going to be doing, and I just want to show you guys this all the way through. I'm going to create one more layer here. This one I'll call Topo Flat. I'll make that one active. I'm going to change the color on this Topo Flat layer as well. And at this point, I'm going to use all of these topo lines. I could actually turn off the surface altogether. There's my topo lines. I'm going to create a flat plane. So we'll do a rectangular plane corner to corner, larger than my topo. There. Then in the top view, right here, I'm going to use the project command. So I'll type in project, or go to curve, curve from objects, project. And again, I'm doing this in the top view. That's important. I'll go ahead and select all of the curves. There they are. I want those curves to project onto this flat plane. I'll press enter. There we are. And for clarity purposes, I'm going to move these over so that you can see them. So what I have here is I have the 3-dimensional curves, and then I have these as if they were flat and projected down onto a map, much like a map would look. These flat curves I can then export into, say, AutoCAD for laser cutting. So I'd go to File, and then Export Selected, and I'd change my Save As type down here to be an AutoCAD drawing, and then I could give it a name, and I'll go ahead and put it into today's folder. And then I'll click Save. So that's writing an AutoCAD file for me to be able to go cut. There are the default scheme is just fine here. There are obviously more steps involved in terms of getting the laser cut file ready to actually cut, what colors the lines need to be, what the layers need to be, all of that stuff. We will cover that going forward. This is just kind of the broad stroke steps of where we're going. We'll get to more precise information as we go forward. Today, it's very much about finding your terrain in SketchUp, taking it, bringing it in, using the curve network in the X and the Y direction to create that grid of lines, using the contour command in the X and Y direction to create that grid of lines, taking the grid of lines, using the curve network on it to create an actual surface, and then taking the surface and slicing it up one more time. What I'm looking for is I'm looking for you to do a screen capture that shows something along these lines, where we've got the contours there, we've got the contours flat. So just go to the little triangle, go to Capture to File. So you don't really need a rendering, just something like this. Go ahead and save that on your flash drive and upload that as your featured image for today's exercise, 211. Next class we'll come in here and we'll continue kind of building it. We'll re-go through these steps again, and then we'll build from it and really start to get ready for your assignment 202. If you find that you don't like your terrain today and you want to switch terrain before next class, that's totally fine. You don't have to stick with the same terrain going forward. So try something out today, see what it looks like, see if you like it, and then we'll go from there.